Hey everyone, it's Dr. Green here. Today we are going to be reviewing make versus buy problems, specifically how they are modeled and solved. So the first question is, what are make versus buy problems? Well, in industry and in various applications, you will have opportunities where you get to choose between making and buying a product. And that is not just a black and white decision. There are trade-offs in there. It's very gray. So we need to decide what the optimal mix of making versus buying is. One way we can do that is to build an optimization model using a linear program in our spreadsheet. So if we take a look at our example, we will use T&L Manufacturing that produces three unique products, X, Y, and Z. I'm going to go ahead and bold information that I find important as I read. This may be a good practice for you as well. Basically, we need to create an optimal schedule of making versus buying, and we know the following. There are two steps, plating and heating. It explains a little bit of plating and heating here, but what we do know is products X, Y, and Z need 12, 20, and 6 minutes each of plating, and we have 15 hours of plating available. We also know products X, Y, and Z need 6, 12, and 3 minutes of heating, and there are currently 1,000 hours of heating available. We also know it is going to cost us $3, $280, and $220 to buy these products from another manufacturer. But if we make them in-house, they will cost us $220, $150, and $120. We also have some demand numbers for the coming month, which we need to meet or beat, and we are going to develop a plan to minimize the total costs for the coming month. So let's begin by writing down our information, and I'm going to start right here at the bottom. We will go in and we will say we have some demand. We know what our demand looks like. It is 3,000, 5,000, and 4,000. Now you'll see these are well formatted due to some things I had in the spreadsheet. I can always change this. I can go in, I can click and unclick these buttons. I can change it to this. I can clear all formatting. But right now we do want it to be decimals with the nice commas. We want to get rid of the decimal places because we just don't need those. That's demand. So I have my demand. The next thing, well, I'm going to skip these guys for a moment. I'm going to look at my plating and heating. I have two requirements. I have plating. Products X, Y, and Z need 12, 20, and 6 minutes of plating. Now, these aren't dollars. I want these to be just like my values above here. So I can do that. Or I can just select this, pick the format painter, and paint the format on my other items. Just a little trick to help you out. I also need some heating. Products X, Y, and Z need 6, 12, and 3 minutes of heating. Again, I want those formatted properly. Well, there we go. Now the one thing we are missing is these are for products X, Y, and Z, so we should say as much. Let's center those and make them bold as well so they look nice. We already have these bolded. We also have two costs. We have production costs, and we have costs of buying or purchasing products X, Y, and Z. Our production costs are $220, $150, and $120. Okay? But the decimal places went away. We want all that to show, and we want it to look like money, so we'll click the little dollar sign. Our buying costs are $3, $280, and $220. Same problem there. We want that all to be dollars, so let's make that happen. The other thing that we do know is that we have a certain amount of plating and heating available. There are 1,500 hours of plating, and there are 1,000 hours of heating. I am going ahead, I'm writing hours there so that I remember that. The thing that is tipping me off to do that is that I know we're talking about hours here, but we're talking about minutes here, so we're going to have to deal with that a little later. All right, so I think this has gotten us all the information we need from our problem. Now that we have that all in place, we have to look at what decisions we're going to make. Well, we know we have three products, and we're looking at how much we make and buy of each. So let's go ahead and write this problem out as such. I'm going to go ahead and move these all the way up here. I'm going to say we're going to choose the number to make. We're going to choose the number to buy. And then these cells right here are going to hold my decision variables. This is the most decision variables that you have worked with this far. So we're going to have 6. If this was a mathematical formulation, which we've already done, we would probably refer to these as x1, x2, and x3, x4, x5, and x6, something like that. So you can easily write down the mathematical formulation for this. Now, normally when we're making or buying something, we want to track the total. So I'm going to put in a row here for the total. I'm going to move it over here. Now I can add up the total just by saying this plus this, and that's fine. You can do that all the way across, but I prefer to use Excel functions. So I'm going to sum up these two. Use the sum function. It just means add them up. And I'm going to drop them all the way across here. You'll see we're at 0. You can test this all around, see what happens. Okay. Now, it looks like I have some old formatting in here. I don't want those to be bold. That's fine. We are going to go ahead and just get those all settled. We'll even center these up so it looks nice. We are going to make these numbers. I do have no interest in seeing the decimal points because we can't really make fractional units anyways. So that's how we're going to do this. All right, so I have that. Now I have my total, and lucky for us, I know that my total has to meet or beat my demand. So that tells me that this is a greater than or equal to constraint. So my total must be greater than or equal to my demand. Now I'm just going to go ahead and shift this whole thing right up here, cut and paste it, so that these are right next to each other and I can see everything that's going on. The next thing I need to figure out is how I'm going to deal with the amount of plating and heating required versus what I have available. So we know we'll need 2 cells in here roughly, one to do our calculation and one for the inequality. In this case, I cannot use more than is available, so that suggests this is going to be less than or equal to. Here we go, so we have this nice inequality. Now, to figure out how much plating we used, we are going to look at our old friend, the sum product. We only use plating when we make something, so we are going to look at the number made. We are going to take the sum product with the amount of plating required. There we go. And we're going to drag it down. Great. Now the only problem I have here is that I am calculating the amount used for each of these resources versus the amount available. And this is in minutes and this is in hours. That's a real problem for us because you cannot compare minutes directly to hours. So you have 2 ways of dealing with this. You can either convert all these minutes to hours, or you can convert these hours to minutes. Either way, you're running into a little bit of a communication problem. Why? Because people generally don't think of hours in fractions, and we also don't think of minutes in large numbers. So for instance, 1,000 hours is 60,000 minutes. That doesn't really hold any meaningful information for anybody. So one thing we're going to do, we're going to take these, we're going to pop them over here on the side. We have products X, Y, and Z. So let's push this down. We'll say X, Y, and Z again. We'll center this up. And we're going to merge and center this and say minutes required per product. Okay, this gives us some good information over here. I have my minutes required per product. Now you can put this anywhere. I prefer to put it here. You could put it down here. Okay, and if you put it down here, you can just get rid of this. But you'll see it sort of squeezes out my title there. I don't really like that, so I'm going to leave it right over here. And then what I'm going to do is I'm going to convert all of these minutes to hours. So I'm going to say this is this divided by 60. Now you'll notice I just put a constant in that formula. That is a very bad practice. I'm going to just drag these through so it's over 60. So I'm also going to put a little cell over here and say minutes per hour, where I can note that there are 60 minutes in an hour. That lets me go over here, and instead of doing 60, I can do this, lock it up, drag it across, drag it down, and we are in good shape at this point. Okay, I have my constraints. I've calculated the 2 constraints that I have. So now I have costs. I have my production costs, I have my buying costs, and I have my total costs. Total cost is perhaps the easiest because it is just the sum of my production and buying costs. So we're going to add that in. We're even going to go ahead and format this cell with our nice double border to demonstrate that it is our objective function. We also know these will all be monetary values, so we'll change them with the $sign. Hey, production costs. Again, our old friend sum product. My production costs are how many I decide to make matched with the cost per unit. Note I am not locking or using absolute referencing for the number to make. Why? Because I want to drag it down and I want both sets of cells to shift down one row, which they do right there. Okay. Now we're in pretty good shape. The only thing we have left to do is to wrap up some formatting. So I'm going to select all these areas at once, and I'm going to add our formatting that we typically use for our given information. A nice blue border, a nice light gray fill. Okay, now we're looking pretty good here. I think we're in generally good shape. So make sure you save your file. You'll notice that I hit Command S all the time. We're going to go over to our data tab. We're going to open up Solver. Now you'll see I have a bunch of stuff already in here. If you do, just hit Reset All. No big deal, it all goes away. I'm going to set my objective. My objective function is to minimize my total costs by changing my decision variables. I'm going to add my constraints. I have my total demand greater than or equal to my total made greater than or equal to my total demand. And I also have the amount used is less than or equal to the hours available. So one greater than or equal to constraint, one less than or equal to constraint. I'm going to change this to my simplex LP, and I'm going to make sure that my unconstrained variables are non-negative, meaning my x1, x2, x3, x4, x5, and x6, the values for the number to make of each product and number to buy of each product. We want those all to be positive. So let's hit solve and see what happens. Now it might take a second here. And it comes back, solver found a solution. Uh-oh, it's all hash tags. All right, what I need to do is change the size of my column so I can read those, and we have a solution. You'll see that we are using a specific amount of our stuff. I'm going to format those so it actually looks nice here. Beautiful. I have my everything up here. My demand is being met exactly. I am making most of my product and buying some of Y. That doesn't really surprise me in a lot of ways, or maybe in a little bit of way, but not that much. And my production costs and my cost to buy are all lined up, and we are in good shape. You have solved your first make versus buy problem.